Okay, let's continue. Okay, so from question 9 to question 12 is the equation solving for logarithm equations. Right, to solve those equations, again, we need to go back to this basic, these very basic definitions. All right, so you see that's when a to the power x equals y. In logarithm form, it becomes logarithm to base a of y equals x, right? So using that facts, you could just get the numbers run for those equations. In this case, that's 4 is the base, right? So it's 4 to the power of what? So remember, the result for logarithm is the index. So to the power minus 2 equals the contents of the logarithm, so which is x. So that means x equals 1 over 4 square, so which is 1 over 16. Okay, the same technique can be used for question 10. So again, 4 to the power x equals 8, right? But this time, the unknown is on the power, so you need to find the x. So against 4 versus 8, do we have any common base for 4 and 8? All right, so you could come up with, use common base 2, 2 square equals 4, 2 to the power 3 equals 8. All right, so then you could see 2x equals 3, x equals 3 over 2. All right. And for this one as well, okay, 2 to the power half equals x. So remember, that's half a power, that means square root. So x equals 3. Right, this one, 25 to the power minus x equals 125. Again, that's 25 and that's 125. Okay, we have similar questions before, so you need to use the common base 5. Right, so let's multiply this. Okay, so easy, right? So let's move on to rather complex questions. These two questions are complex familiar. Okay, how can we solve those questions? Okay, so when you observe, there's a logarithm square and equals something times a logarithm. Okay, so you see that logarithm, okay, is the same. All right, and how about that's a square, right? So see, that's a square. Okay, so to solve these kinds of questions, normally we need to think of this as a quadratic. Try to think this as quadratic. Okay, what do you mean by quadratic? Quadratic means you need to see something like a times x squared plus bx plus c, right? You need to have that thing, right? So in this case, let's just let u equals logarithm 2. Then we'll convert this one into a quadratic equation, right? The left-hand side, because you now use u equals logarithm to the base 2 of x, so it becomes u squared equal 2 times u plus 3. All right, so you just move the terms to the left-hand side. Okay, right now it is a quadratic form. You can use your cross method or method of decomposition, whatever you like. Do things like this. Of course, I'm not going to do the method of decomposition or cross method again. This is just normal quadratic equations, right? So let's continue, and we use null factor law. 0, that means u equals 3 or u equals minus 1. Remember, what is u? Use logarithm to the power to the base 2 of x equals 3. So again, logarithm to x minus 1. Right, so there are two logarithm equations. So what I'm going to do is 2 to the power 3 equals x. 2 to the power minus 1 equals x. So x equals 8 or x equals half. Okay, so that's how we solve it. Okay, so the next question, okay, it's the exponential one. So the difficulty in this question is, you see this is base 9, this is base 3, so they are not the same. All right, and also you have minus 27 here. So that means you can't do it like what we did before. You can't do things like what we did in those simple questions. These things are simple familiar. For those questions, it's easier because you can have power form on both sides. But this one, you can't do that with this one. You can try, but it won't work. How can we solve this one? So if you observe, you could see that's 9 is 3 squared, right? So let's just try to write that 9 as 3 squared to the power x. To the power. Okay. Okay, so for this one, we understand this is just 3 to the power 2x. Okay, so I'm going to think about this term a little bit more. Okay, how about this thing? We know 3 to the power 2x can be considered as 3 to the power x 2, right? You just move that 2 outside the bracket. Okay, so if you could see that, that's 3 to the power 2x can actually be considered as 2 to the power x, the whole thing square. Okay, so does this look like a quadratic again? You have 3 to the power x and then square. You have another term which is 3 to the power x. Okay, so this is looks like a quadratic. So let's let u equals 3 to the power x. Okay. So after this, I'm going to have u square. All right. So because 3 to the power x is u, then 3 to the power x bracket square becomes u square. Minus 28u equals minus 27. So it looks like a quadratic. To solve a quadratic equation, you always need to move the terms to one side. Okay, now you have u squared minus 28u plus 27 equals 0. That means this one's a quadratic again. Okay, so I'm going to use method of cos method again. Yeah, it's just like this. All right, then you see u equals 27, or u equals 1, and that's 3 to the power x equals 27, or 3 to the power x equals 1. Again, you see two exponential equations. Then we can use the common base now. How about 1? 1 is just 3 to the power 0. So we solve it. Okay. Right. So for both question 13 and 14, you see sometimes we need to let u equals a logarithm. One need to let u equals to a exponential equation, exponential form, so that we can convert them into quadratic, so we can solve them. All right. So this technique is it's a bit difficult than the things we've learned before, right? But you need to use them in the exam if you see such a questions like this. Right, so then we go to the last question. Okay, so this one is technology active. So I'm going to show you how can we use technology to solve these equations. All right. Okay, first of all, when you see the question, this is about the depreciation value of the car. Okay, modeled by this one. So this is an exponential equation. So again, you need to see the definition of those dependent and independent variable. Dependent variable is v, which is the value of the car, and independent variable is t. T is the number of months. Okay, remember that's months after the purchase of the car. Okay, so and normally because you can use calculator, so you would try to get the best out of your calculator, right? Okay, so the first thing is about purchase price of the car. What do you mean by the purchase price of the car? That means the price you pay for the car when you bought it, right? So that means what you're going to find is just V0. Okay, because some of you must know how to do the substitution, but let me just try to do it using calculator because that's paper 2. We will try to use calculator, right? Okay, let me get, okay, I'm going to, sorry, I'm going to quit, so I need to do it over again. So, new document, I'm going to add a graph. Okay, so you see in the calculator, you must start with f1x. So that means you can't use the same variable as in the question. So in the calculator, in your calculator, what you need to input is f1x equals 26000 e to the power, 4 to the power minus 1x plus 1000. Okay, that's what you're going to put in. Okay, so you need to use the power. Okay, you need to use the variable as x and y, all right, rather than v and t. Okay, now let's go back to the calculator. Let's input the whole function. Okay, so you need to press this multiplication from to the power minus 1 x. So remember, it's now not t, it's now x. Okay, so when you input the graph, you can't see it right. Okay, because sometimes the scale is not right. Okay, so you need to do the zoom. Which zoom shall we use? Okay, so there are many different types of zoom. The one you want to use first is the zoom to fit. Okay, so that will give you the whole data. Okay, and you might try to do a few things because we try to make sense of the data, right? Because we actually, in this case, the negative value of x is not going to be meaningful, right? So there are a few ways to do it. One way, you can just go back to the function and you can use, okay, I will show you what to do. You can go to control, you click this one, okay, use this one, okay, then you input x. All right, I want x greater than equals 0. Okay, then you just cut the curve, so you restrict the domain of the function, and right now it looks a bit better, but we still want to zoom onto the graph, right? So let's see if we could do it. Okay, so I use another zoom. I'm going to use zoom box. So first corner and second corner. Okay, so now that looks good. It looks much better, but still you see the x value is only up to 9. Is it going to be enough? No. So let's see the questions. So in the questions, there are 2 years. So, but our t is in months. So 2 years means 24 months. All right. So we need to be a bit careful because now the t here is only up to 9. So that means we need to have greater to display a greater time t, right? So on the calculator, we need to have a greater x value be displayed. So I'm going to do the zoom again. So this time I go to window setting. Okay, so I'm not going to touch on the y value. Y value seems fine. So I'm going to go to the x maximum value and try to get more x value. So remember, you need to display up to 2 years, so that's 24 months. So how about let's do it like 30 years. Okay, so here's the graph. Okay, and you need to escape. Right now, still on zoom. You need to escape, right? Okay. So what I'm going to do now, remember the questions. You need to find the initial value, V0, V0. Okay. So I'm going to use a function which call trace of the graph. So just graph trace. Okay, so you see there's a point. So you just move the point towards one end of the graph until you hit it. So you see that's 0. Okay, so that means right now the x is 0. You just press enter. It will show you the point. Okay, then you press escape. See escape. All right, now you're out. Okay, so you see the value of x is 0, but how about the y value? It seems like 2.7 e plus 4. What does it mean in your calculator? Okay, let me write this. Okay, this is the display in the calculator. Right? So that means on your paper, you shouldn't write this as your answer. Okay, but you could write this one as your answer. Okay, and this one actually means 27. You move, so that's scientific notation. You know what I mean? You just move the decimal point to the right by 4 units. Okay, that means $27,000. Okay, good. So that's how we find the purchase value of the car. Okay, right. Determine the depreciation value of the car in 2 years. Okay. Okay, what does it mean in 2 years? What's the depreciation? Okay, depreciation value means the drop in value, right? The decrease in value. All right, so that means not the value after 2 years, but the decrease in the value. Okay, so the depreciation in the value should be V0. That means your initial value minus, how about 2 years? So remember 2 years means 24 months. So t equal 24 months. So I need to input 24 here. So what I'm going to do now is going to the calculator to find V24 because we've already got V0 as 27,000. Okay, let's try to get this one. So I go back to the graph again. So now I'm going to do the trace again, right? So I'm going to do the trace. So I need to go to 24. I go all the way. Okay. Now 20, 21, 22, 23. 24, right? So remember, you need to press enter and then you press escape. All right, so you got the value. So now the value is so the y value is 1.93 times 10 to the power 3. All right, so let me copy this. 1.93 times 10 to the power 3. Okay, and you could do that in your calculator, right? Okay, you could just do the calculation in your calculator, but I've done the calculation by myself. So that would be the answer. So the depreciation in value is $25,070. Okay. Determine the time the value of the car is only half of its purchase value. Okay, so how could we do this? All right, so we know that you need to find the t. You need to find t such that Vt equals half of V0. And V0 is this one. All right, so that means you need to solve Vt equals. Okay, how could we find t? Again, you can go to the calculator to solve this. So in your calculator, what I'm going to do is I need to sketch a vertical horizontal line. Okay, I need to get like f2 x, which equals that 13500. Okay, so let's go back to our calculator. So I'm going to create another graph. So I'm saying tape again. Oh, sorry. Okay, so when you tape, you see F2. Okay, so what I'm going to do is just I'm going to input a value. Okay, so then you see a red line. Okay, so that means on the red line, the values are always $13,500. Okay, so what I'm going to do is to find the intersection of these two graphs. How could we do that? All right, so we go to the menu and you need to do analyze graph. Okay, so there are many options. Of course, you are going to find the intersection. Okay, and you need to find the lower boundary, the upper boundary. Okay, then you get a point. So the point is the t equals 5.28, and the y value is just the value half of the initial purchasing price. Okay, so we form the graph. We know that it's 5.28. Okay, so you see, form the calculator. Form the calculator. We just see t equals 5.28. Remember, this is months. So that means after 5.28 months, the price for the car will be half of its initial value. Right, the last one. Okay, determine the average rate of depreciation during the second year after purchase of the car. During the second year. So this is a tricky part. Okay, what do we mean by during the second year? That means from the end of 12th month to the end of 24th month, right? So because second year is from 13th month to 24th month, right? Okay, so what I'm going to do is like I'm going to find the second year. So the 13th month to 24th month. Okay, so the average rate of depreciation, I'm going to use this one, B, okay, V24 minus not 13 but 12. Why? Because all these when you say V12, that means the end of 12 month. Okay, so that's why you minus V12. Okay, and so that's the average rate of depreciation. Okay, then you need to find what do we mean by V24. We've done that before. That's 1930, but we haven't got V12, right? Have we? Right. So we need to go back to the calculator to get V12. How can we do that? Again, we're going to use the trace. Trace. All right. I need to move back to 12. Okay. So enter, escape. Okay. So you see that's the value of the car at the end of 12 months is 5.93. Okay. Is 5.93 times 10 to the power 3. Good. And that would be 1930. 12. Okay, use your calculator. You get this one as per month. Okay, so that means every month, in average, the value dropped by $333. Okay, so that's it. Okay, so this is the last question. Okay, so if you still have any doubts about those solutions, you could come to see me. All right, good luck. See you later.